Hello students, hope you're doing well. In this video, we're going to look at vectors. What is a vector? A vector is a physical quantity associated with magnitude and direction. So any quantity which has both magnitude and direction is known as a vector quantity. Right? Now why do we need to study about these vectors? Let me take an example. Let's say I take a box. I push this box 5 meters this side and again push it once more 5 meters this side. So what is the total distance, total displacement of the, total displacement of the box? It is 5 plus 5, 10 meters. Now I'll take the same box, push it 5 meters this side and then push it 5 meters this side. Now what is the total displacement here? 0. That means here you can see that I'm, putting the same effort twice. One case I'm getting displacement as 10 meters and the other case I'm getting displacement as 0. That means what? Even though the efforts are same, it is the direction which is making a difference. So in order to understand these kind of quantities, we define vectors. So all these quantities which have dependence on direction also are called as vector quantities. Now how do we represent a vector quantity? A vector quantity is represented by a line segment, something like this, with an arrowhead. The length of the vector quantity is directly proportional to its magnitude, and the direction is along the direction in which the arrowhead points, right? So what do I mean by length proportional to magnitude? If I have a 10 units vector represented by 1 centimeter, then 20 units would be represented by 2 centimeters. That's the meaning of length being proportional to magnitude. And a vector can be shifted parallel to itself anywhere in space. Now let's see what are equal vectors. Two vectors are equal if they have same magnitude and same direction. Okay, so what should be equal? The magnitude should be same and direction should be same. You can see that I can say AB is equal to CD. Why they're equal? Because both of them are parallel, that means direction is same, and you can see that the lengths are also same. That's why they're equal. Another example, we have Beck and Sam. Now Sam, is applying a force in this direction. Here dB and ds are the forces applied, and we said that both of them are applying in same direction, so both the forces can be said to be equal. So if two vectors have same magnitude and same direction, then they are same everywhere in the world, right? It might be in New Delhi or New Jersey or anywhere else. So if two vectors have same magnitude and same direction, they are equal vectors. Now how do we find angle between vectors? Now why do we again study about this angle between vectors separately? The reason for that is, if I have two vector quantities, let's say I have one vector quantity like this, let's say this is A, and I have another vector quantity like this B. Let me assume the angle between them is 30 degrees, right? Now if I extend this like this, I can have this angle also. Now what will be this angle? This angle would be 330 degrees. Now I can shift a vector parallel to itself. Look, so let's say it is A, this is B. Now it's given that this is 30 degrees. In that case, this will be how much? This will be 150 degrees. And if I take the exterior angle would be how much? It will be 360 minus 150, that is 210 degrees. That means I'm having four possible angles between two vectors. So if somebody asks me what are the angle between two vectors, I can't say 30, 330, 150 and 210. So I need to have a specific definition for angle between vectors. So we define angle between vectors to be the angle between them when they have their initial points are together and the smaller angle between them is measured. That's what is angle between vectors. Hope you could follow that. So what is angle between vectors? The angle between vectors is always measured as the smaller angle between them when their initial points are together. So here it is alpha, that is angle between vectors. So in this case, angle between A and B would be 30 degrees because that is the smaller angle. Now let's look at addition of two vectors. So if I have a person starting from point A, I'll just take this as a reference, the figure itself. Let's say he starts from point A, goes to B and then goes to C. Now it is equivalent to the person going from A to C. So I can say if I take AB to be one vector and BC to be other vector, then the net effect of both of them, which is AC, is the resultant of two vectors. So I can write R equal to A plus B. Now this law of addition of vectors is called triangular law of addition of vectors. Here we can see that we call the tip of the vector as head and the rear of the vector as tail. So if tail of the second vector coincides with the head of the first vector, then a vector joining the tail of the first vector to the head of the second vector is the resultant of two vectors. So this is what is also triangular law. You can see that if two vectors are represented in magnitude and direction by the sides of a triangle taken in order, then the resultant is represented in magnitude and direction by the third side taken in opposite order. So that's what it means. Now let's say I'll take a simple example. Let's say a person moves 3 meters towards east and then moves 4 meters towards north. Then his resultant of these two, resultant displacement is what? Under root of 3 square plus 4 square, that is 5 meters. So if I take this vector as A, this vector as B, this vector as R, then we have R equal to A plus B. Here you can see that 5 is not equal to 3 plus 4, but the net effect of these two vectors is having a magnitude which is equal to 5 units. Then we have parallelogram law of vectors. Parallelogram law of vectors is nothing different, but if I have triangular law, like if I have this as triangular law, I say this is A, this is B, and then this is resultant. Now if I shift B, this side, this is A, this is B, then this becomes resultant. This is parallelogram law. So how do I define it? I'll put it in words. I can say if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram, then their resultant is represented in magnitude and direction by the diagonal of the parallelogram passing through the intersection of vectors. You can see that BD is the resultant of vector A and B. So if I shift this B here, this becomes triangular law. So parallelogram law is other way of looking at triangular law. Now from parallelogram law we can derive the relation R equal to under root of A square plus B square plus 2AB cos theta. This is what? This is the magnitude of the resultant, and tan alpha, the angle that the resultant makes with one of the vectors, in this case A, is what? It is given by B sin theta by A plus B cos theta. So this part gives us the direction of vectors. So in this way parallelogram law can give us the magnitudes of the vector and the direction also. So that's why when we have two vectors, triangular law and parallelogram law are very useful for us to find the resultant of the two vectors. Now subtraction of vectors. Now when we talk about subtraction of vectors, there is actually nothing called subtraction existing in the universe, because we have something, an action done. Now I can't go back in time and undo that action. However, I can do another action in opposite sense so that the first action and the second action are neutralized. Similarly, when we talk about vectors or subtraction of vectors, if I have two vectors A and B, then I take a negative of vector B. Now what is negative of a vector? A vector with same magnitude with opposite direction. Now once I have vector A and minus B, if I find the resultant of that, I'll get that as A plus minus B. A plus minus B would be the negative of the vectors. Fine. So from this we can see that the negative A plus minus B would be the difference of the vectors. So what is difference of vectors? Addition of a vector by the negative of the second vector is the difference of vectors. Hope you could follow that. So subtraction of vectors is what? Addition of, and once you have A and minus B, you can use either triangular law or parallelogram law to find A minus B. Now, so if I want to see further things, like if I talk about formula and everything, I want to see how we get the formulas of all those things. Magnitude will be what? Magnitude of addition is what? Resultant, that is equal to under root of A square plus B square plus 2AB cos theta. So magnitude of A minus B would be equal to how much? Under root of A square plus minus B whole square plus 2 into A into minus B cos theta. So in this way we'll get magnitude of difference of vectors to be equal to under root of A square plus B square minus 2AB cos theta. So this is the only difference. In addition and subtraction of vectors, there is a negative sign, and again don't get confused here. This angle theta is the angle between A and B, not A and minus B. So this theta that we are considering is what? It is angle between A and B. So don't take it to be angle between A and minus B. And this is how we find negative vectors. Hope you could follow what all things we have done. We just had a quick review of what are vectors, how do we represent them, how do we find angle between two vectors, how do we find the resultant of two vectors, and how do we find the difference of two vectors. Hope you could follow this. Thank you very much.